It's actually time.
Oh,
I go and close the door and
let me do this.
oh, okay. And you can see if you can see Greg also. So it's obviously something with the brakes here in Bangkok. People are very, very reluctant to leave them and come to the meetings. So if we are quick about it, we can take a lot of decisions now and then go and do something else. I was about to say that we have something odd here. We have two chairs that has nothing to say. We want to start. The only problem with that is that the first presenter is Greg, and he's as far as I see not in the room. Can someone like Martin help us to find him? I have one further comment. I presented a long list of Sleeping Beauties at the last meeting, at the meeting yesterday. I have got some response. I want more. I'm going to send the list out in the mail so you can review it and see if you have anything there. It actually, I look at the list now and then and see that there are things there that I think we done right. There are things in there that I think we done wrong. And there are documents that actually would like to progress even if they're 2 or 3 years old. So, no Greg. Do we have a... Who's next? Oh, Greg, run. I've been that all morning. No, take your time. Do it. No, it's... Yeah, quick, but correctly.
Good morning. Thank you for your patience.
Somewhere. Oh, yeah.
So, as you can see from the draft short name, it's OEM for SRMPLS over IP or over UDP. So what's in scope? It's a fault management, on-demand fault detection, localization, characterization, proactive monitoring, path continuity, and performance monitoring, delay measurement, and packet loss measurement. Fault management, so we have RFC 8287, which explains applicability of LSP ping for SRMPLS. And that pretty nicely describes ping and trace route over SRMPLS and works SRMPLS over IP seamlessly. Draft Mirsky Spring BFD so describes applicability of BFD over MPLS LSP in SRL MPLS domain. And again, there is no issues to use it for SRMPLS over IP. Both documents, RFC 8287 uses recommendation for 8089 IP UDP encapsulation. If someone is looking for non-IP encapsulation, then there is an issue with preserving source ID. Source ID can be preserved using IP address TLV proposed in draft that discusses MPLS applicability of point-to-multipoint BFD. Performance monitoring. RFC 6374 packet loss and delay measurement in MPLS networks is entirely applicable to SR MPLS, and there is no issues using it in SR MPLS over IP. So the conclusion is that existing OEM mechanisms in MPLS networks, they work in SR MPLS with very minor extension that doesn't require really a separate specification. But there are some other interesting issues coming from the fact that when we're doing SR MPLS over IP, we're creating multi-segment tunnels. And with multi-segment tunnels, if we lose identity of the source, then there might be some interesting issues that I'm planning to explore and see what happens then. I discussed with one of the authors of SR MPLS over IP whether there is a reason to have a separate document or have it as a section in SR MPLS over IP document. But suggestion was that since this document is mature in close to working group call, so probably it's not a good idea just to merge anything in and restart the discussion. If anything that will be of substance in this document, it can proceed as a separate document. So for now, welcome questions, comments, participation, contributions. Yes, please.
I just have only one comment. For SR MPLS or SR in general, there is also SPFD-based solution for SR policy, and that also works as is without any change.
It's a valid comment. Thank you, Zafar. I'll add this reference and in a document so that it works seamlessly. Yes, I agree. Okay, thank you.
Next is Zafar.
Thank you. Thank you. So this is the latest slides.
Not the latest slides.
Yeah,
Okay, we have to get the new set of slides. They have updated them and we haven't really uploaded.
Thank you. Thank you. That's good. Yeah, this is good. Thank you. Thank you very much. This is a work that we started for extension of MPLS LFP ping and for SR MPLS based LFPs. I'm going to present it on behalf of my co-authors. So the main thing is that initially RFC 8287 was defined fact types for to be used in SR MPLS network for prefix SID and agency SID. And there were related procedures that are fully defined there. This draft addresses some fact types that are not addressed in the base RFC 8287, Specifically, the base RFC doesn't talk about BGP prefix SID FAC. So we added a statement for that. BGP EP SID, incidentally, like us found this gap as well as Shraddha, who presented this yesterday in Mpls working group, found the gap as well. So there are two drafts that talks about BGP EPP FAC type for BGP EPE SIDs. And as I go, I'm going to just highlight some differences, but there is some discussion going on with Shraddha for collaborating on that. And then last but not least is the binding SID. So that's the problem statement here. So for the BGP prefix SID, there is basically no need to define a new FAC type. We can use existing FAC and just define that we can use existing FAC. This is just maybe clarification statement because implementations are already using this implicitly. So I think this should be a non-issue. Then the second one is the BGP for EPE. So EPE has three different types of SID. One is the peer node SID, and then you have peer agency SID, and then you have a peer set SIDs. So that is defined in the EPE, BGP EPE draft. Now here, this is an encoding for the FAC for BGP EPE peer node SID. Here, the information you find would be very similar to what Shraddha presented yesterday. With the in the procedure, there is certain changes, and that basically we also try to highlight or address the case where when you go to the neighbor of the BGP EP, the node that is advertising the BGP EP SID, and you go to neighbor of it, and that neighbor may not have, because it's a different AS, it may not have a route back to the source, or it may not be even an MPLS router. So in these cases, the neighbor cannot respond to this request, and then we put some consideration that I will go at the end of the talk. So this is something that were different from the draft that were presented yesterday on BGP EP SID. And the other thing is also that what we notice is sometimes, because this is a peer node SID, it is possible that the ingress who's trying to validate this peer node SID may not know the interface addresses. It may or may not know. So that's where the I flag is set to say that interface addresses to be ignored because the peer, the sender may not know that, and that's was not there in the encoding that was presented yesterday by Shraddha. But minor difference. And then the same thing with respect to the BGP peer agency SID is there is no need for that flag here because this is agency SID. So you know the interface for sure. So you notice that there is no I flag in this case. But in terms of whether when you go to the peer agency, the problem still remains there. The peer agency, the BGP peer may be an IP router or may not have a route back to the source. And then last is the BGP peer set SID. So we had discussion just during last 2 hours in a spring working group with Shraddha or Mike, and she agreed that when we have the peer set SID, we need to basically, we have the local information, the node that is advertising this peer set SID is the same entity, it's the node. So we don't have to repeat the local IDs, local router ID and the local AS in the encoding again and again. So what here is done is that is through defining these sub TLVs, which are actually encoded same way as previously encoded for the peer agency or as pair node, those can be carried for all the member that are part of the set. But these member may be in a different AS. So this is where this encoding can take care of that, because there is no one pair. All the pair doesn't have to be in the same remote AS. So that is addressed here as well. So so encoding is pretty straightforward and is almost similar or very close to share the draft. Then the second or another SID type that we were addressing was the binding SID. So binding SID presents some interesting problem or interesting question, which happen to be similar to questions that you will face if you have EP SID and you go to a router which is non-MPLS. So basically, and here is solution wise the same, but the question is that if you want to validate the binding SID, and if you set packet with the binding SID, then it's going to get switched into the tunnel, and the endpoint, the LSP will appear as IP at the node which is the last SID of the binding SID. So here we try to address that a way that we can get to the head end and just try to validate from that head end that do you have this binding SID. And the binding SID is identified by head end address, color, and the endpoint. So basically, the procedure-wise, we say that if you just want to validate the binding SID and you don't want the packet to be switched to the egress of the binding SID, then you can set TTL of 1. And this is something is there in the base RFC is allowed, is used so that packet doesn't get switched. The innermost label packet set to 1 is mentioned, but what is not mentioned is that the fact validation. So in this procedure wise, what we'll be saying is that when node receives this binding SID and TTL is set to 1, so it basically validate that do I have against this label or binding SID, do I have a corresponding control plane state that matching my head end router ID, the color, and the endpoint in the fact. That's what the graph is saying. And then we can do the same thing when we know that the neighbor of EPE node, if the neighbor of the EPE node is an IP neighbor or it doesn't have route to the source, then we can terminate that on the ultimate hop by setting the TTL value to 1. And the fact validation would just be basically checking that if that particular SID is a local SID, any that would rise. So with that, we'd like to get your feedback. We actually was not sure whether this work will happen in spring or in Mpls working group, and these slides are made for the spring, same slides. So this would be really up to the chairs to decide where the work will go. And the second point is that we are talking with Shweta on the other draft on collaborating. So I think at the moment, maybe best is that we get the comments on the list and then ask chairs what is their opinion. Let's say, given that we agree, if we agree, would you go ahead and adopt the work or any guidance if you can provide?
So can I ask who has read this draft? Almost a handful. I have a couple of questions. Can you go back to the first definition of the TLV?
First one.
Well, anyone would actually do, but...
This is the prefix. This is the existing TLV.
Oh, no, the next one.
Yeah. This is the peer node.
You have two You have 4 or 16 octets as
Oh, because the interface that you have with the interface that you would have with your BGP egress pair could be an IPv4 interface or IPv6.
I understand. How do you know which one it is? I hope the answer is obvious because
Okay.
I just don't miss it.
I mean, that's something that the sender, if sender knows, then it puts there for the pair node SID. And if it doesn't know, then it put the I flag that I don't know, it's the address. So because this is really the FAQ is really pair node. So it should go to the correct node. I mean, from a FAQ definition point of view, it needs to land on the correct node. So that's where the I flag would be set.
The I flag indicates whether it's an 4-octet or a 16-octet.
No, the I flag says that whether it is to be ignored or to be considered. But I think your point is different. You're saying that how do I know that whether this is a 4 or 6? And that could be done by the LAN, or we can put something explicit. Oh, address family. There's address family type. EF type.
You have the question, so you can go home and consider it.
No, the address family type would. AF type would say whether, there's AF type. Yeah.
Okay, thanks.
Yes, that's the answer. Yeah.
It depends on the address family. Okay. You had a May in one of the slides. Can you go to that?
So for the
So wait a minute. So we have an OIM packet, and we say it may not be leaked out of the domain. I thought that there is a kind of a general rule that the OIM packet must not be leaked out of the domain. I would like you to consider what you should have here: may, should, or must.
That sounds good. That's a good comment.
Okay. No further questions from me. Anyone else? So we should coordinate with the Spring shares and see where this work goes. So I have a feeling I know where it will go, but we should make a decision on that. Okay.
Sounds good. Thank you.
Thank you.
Thank you.
And next is C.
Hello, everyone. Jin Rong from Huawei. I present MLDP and RCPT protocol extension for beer. Okay. The two drafts has been updated to 01 version. Address the comments received from IETF 101 about MBB. And also allow the comments on beer working group. They say the new defined FEC will need to overlay change. So I will also have some considerations on this.
Yes.
Okay. Okay. Make it before break. It's a strong requirement for multicast. The key to gain the MBB in multicast, we can review about this. We need a very dynamically change on the incoming interface. For example, both PIM, MM, and MLDP use this technology to support MBF. But IGP-based beer, we have reviewed about this. It's difficult. It may be difficult to support MBB because beer don't use RPF or upstream check mechanism. And one BFR is responsible for stirring at many downstream BFER. And different line cards may be responsible for different downstream BFER. So it may be difficult to do a one-shot change on two different line cards. But it seems to be fairly easy for P2MP LSP-based beer because the already defined mechanism is useful for building P2MP LSP, just with a little extension with beer TLV. The key to the P2MP MBB is that a router allocates different labels for different upstream interfaces to the same P2MP FEC. So the MBB seems to be a significant benefit of this solution. And also one possible impact is that a change of forwarding bit mask need to be known through the path to the root. So the convergence may be slower than the normal P2MP LSP. Another problem, this is from beer working group. They say we defined a new FEC, so we have to change our BGP MVPN protocol because we need a new type of FEC. You can see in the picture, BGP, IPMSI or SPMSI AD route need to carry the FEC. If we define the new FEC, then we need to add the new attribute in BGP. So how about using existing P2MP FEC? I think it's possible. And here we list the message, the mapping message. For example, D send the mapping message to C with a label 400, and also a beer TLV with label 401. This label is for beer set 0, and the label 400 is for the inclusive P2MP talo. Also, F send to C, E send to B, and C send to B, B send to A. We can see this will build totally 4 P2MP tree. One is for the inclusive P2MP, and the other 3 is for every beer set. For example, BFRID 1 is in set 0, BFRID 257 is in set 2, is in set 1, and BFRID 513 is in set 2. Then we have 3 P2MP LSP for them separately. This is the P2MP based beer forwarding, and we can say that the special is this. The label is both P2MP and beer label, so this can be changed hop by hop, just as the P2MP forwarding. And another important is the bit string carried in the beer header can be unchanged, also can be changed. But this capability of unchanging the bit string is important to bypass. If this router don't have the ability to pass the beer header bit string, then it can bypass this packet to the next to the downstream router. So this is the forwarding and encapsulation. Summary. We believe that it's a simple way to introduce beer in the current P2MP deployment for at least the following reasons. One is make before break. IGP beer may be very difficult to support. And the second is multi-AS beer deployment. Because if we want to deploy beer spanning multi-AS, then we need to change OSPF, ISIS, BGP for beer, while MLDP is protocol independent, and the recursive FEC can easily reach the root IP accessing any area AS. And the second is bypassing. So many effort has been thrown into the bypassing of some beer incapable routers and turns out to be very complex and the side effect. But this simple way only need to extend the MLDP. And we leverage the already supported P2MP forwarding. So next step, we will update the MLDP beer extension using the original P2MP FEC instead of a new FEC type, and update the BLTLV accordingly. And also we plan to add the BLTLV used with recursive FEC for building inter-area P2MP LSP with beer. So that's it. Any comments?
Hi, Tarek from Cisco. So my question is, we are signaling a P2MP LSP for every tree here, right?
Yes.
I think this is what you're presenting. It's not clear how how this compares to the existing P2MP LSP's signaling. Is it better? Or is it equal? What are the advantages you're bringing in? That's one. The other thing is I sent an email on the alias, and I think you responded, but it wasn't clear your response. The architecture states that we shouldn't be creating states, control plane states, when we are forwarding this multicast tree in the core. And you are creating states in this case.
Yes.
So not sure how is it not violating or violating that assumption.
Okay, thank you. The first question about comparison of this solution and the existing solution. I think the page have summarized this point. And for the second question about whether this solution violate the beer architecture, because there is some description in beer RFC or beer drafts that beer doesn't need any tree building protocol, but it is not a constraint. I'm sure it is not an assumption that beer want to kill P2MP or something. Also, there is text in the beer architecture RFC said it allow run beer over some multicast specific tree. The question is only that the multicast specific tree is built by MLDP or by IGP. IGP, of course, is possible, but MLDP is also an existing protocol that easy to be reused. So, summary, I don't think it violates any of the beer architecture.
Tony P. Juniper.
So architecture side, human rationalization is a wonderful mechanism, but this goes pretty far. One of the major reasons that beer happened was that we wanted to get PIM and MLDP out of the networks. Well, customers wanted. So if you now introduce MLDP to run beer to get rid of MLDP, you ended up in a pretty indefensible spot, but you know, good luck.
Thank you.
Did you have an RSVP? Did you have an RSVP draft also? That one?
Oh, we have matched in this one.
Oh, okay.
Okay, thank you.
Okay. Thank you. Any other questions? So, last but not least, Kireti. And Kireti is actually talking about a set of drafts that is not entirely within the MPLS working group on resilient MPLS rings. The reason I asked Kireti to do this is that we will need to do some type of coordination work in the working group chairs.
Okay, thanks. Does this work? Sometimes? Yeah. Okay, yeah. So yeah, there are, the RMR drafts have now been spread over a few working groups. The base draft is in MPLS. There's some other drafts in MPLS, but there's some drafts in Ts, and there's some drafts in, there's one draft in Spring. And there's also a draft that's missing that I'll talk about at the end. But these are the things that we want to make sure we have the right allocation, and that's where we want to keep them. And Lou at the back of the room is smiling away. Whoops. So we have the base draft, and that's almost ready for a working group last call. There were some comments on the list that have been addressed. There is one small change that I want to make here, which is the set of supported signaling protocols for this has right now LDP and RSVP TE. It doesn't have a place for Spring. I understand that Spring is not a signaling protocol, but it's a way of creating LSPs, and we want to add that to this before we progress this to working group last call. The LDP extension draft is pretty much ready. There were several comments from the list, and I'm not going to go through the idea. I mean, hopefully you know what that is. But the basic idea for all of these drafts is that you create these two counter-rotating LSPs, and then you use the other direction in case the direction that you're going in doesn't work. So the LDP draft became a working group document in July. All the MPLS RT comments have been addressed. The diagrams have been corrected, and so there's a new version out. And so the next steps, according to authors, is that this is ready for working group last call. We believe this is the right place for this. This is the only place where we do LDP, so that at least is easy. There's a couple of drafts in Ts, the RMR RSVP extension, and that's a working group document in Ts. There is Jeffrey's document, which is a proposal for how to do point-to-multipoint with RMR using RSVP signaling. We believe that that should be in Ts. We're open to, arm wrestling between the chairs, but that's where we think it should be. Comments?
Not really a comment. It's just what we lack is just a decision.
Okay.
And yeah, I think kind of agree with that. We should go to Ts.
You're okay with that, Pawan? Okay. Thank you. So let the minutes state that Pawan is fine with that. Then there's the RMR drafts that are individual documents. There's Jeffrey's draft on how multicast should work in general. A 0.0 version was presented at the last IETF. There's some feedback, and they still have to be incorporated, so they will be in the next version, at which point the authors will request that it becomes a working group document. So right now it's individual, and that stays in MPLS.
So do you see any reason to actually make this a working group document before we go to working group last call with the LDP draft?
They're independent. This is multicast, LDP is unicast. And then, of course, the last draft that we have in the system is a very new draft that's in spring. It was presented for the first time. It was unfortunately a little hastily written, but there's definitely a lot of work that needs to be done. We think that it should belong in spring, but again, we have Bruno here. Do we have Rob? We have Bruno.
Bruno's there.
Everyone's pointing in the other direction. That's fine. So do we think this should be in spring?
I'm not clear yet, but I think we should discuss it between the chairs.
Okay.
It's not. I don't have a strong feeling either way.
Bruno de Crane, Spring Co-Chair. So the draft has been presented this morning, so it's very early. No discussion on the draft, so it's very, very early. The draft can eventually change. It's not.
Will change, yeah.
I don't think we are at the time of working production, but so far I don't see any Mpls extension, and I think it's mainly spring.
Yeah, in fact,
I should be honest. The reason I don't have an opinion yet, I haven't read the draft yet, and I was not in the spring working group this morning. So I need time to read, and then I probably will say spring, but.
Okay, so let's postpone the decision for the 01 draft or 01 version. I'll keep the name as spring for now. I'm happy to change it after that. The 01 version will probably have some changes in terms of new SID types, in which case it does become a spring draft.
It becomes, yeah.
Yeah. Okay. So that's the current status of the drafts that we have in the system. There's one draft that should be in the system that isn't, which is a draft in link state routing that says what's the exact TLV formats and procedures so that you can, define a ring and have everyone agree on what the direction, what's clockwise and anti-clockwise and so on. So the general format of this is in the base draft in MPLS, but the specifics for ISIS and OSPF should be documented. And of course, they need to throw things at me and maybe at MPLS. So it's a question. I mean, that draft needs to be there. What should we do in terms of timing? Do we want that draft to progress simultaneously with the base draft? Does the base draft, can it point to this as informative?
So my answer to that question, and there might be other answers from other working group chairs, but the thing is, I don't want to lockstep. No requirement, but I want them to progress as close together as possible, or reasonable, maybe. Yeah.
Okay. Yeah. So there's not a whole lot to do there except to write it down. But I will.
That will be done soon.
Yes, before the next IETF, right? So that's basically the set of documents. So we have the base document in MPLS and a few other documents in MPLS. A couple of documents in T's, one in Spring, and then one in LSR.
Okay, questions to Kireti?
People are hungry. Okay,
Yeah,
I get it.
okay, they're going to run for food as soon as we close the meeting. I have one more thing. The RMR LDP extensions are, as Kireti said, almost ready for working group last call. I think it's a little bit premature. I would like to see some more discussion on that. So please go home, read the draft, comment on the list, and hopefully we can go for a working group last call after Prague.
Yeah.
Yeah.
Okay. I will also poke Santosh to start the conversation. Yeah.
Okay.
And Dan, I'm happy you're shaking your head because I don't want negative comments on the draft. Okay. So, and then for the RMR, I will do one more, the base draft, I'll do one more version, and then we should be ready to go for that one as well.
Okay. Thank you.
Thank you.
Any comments on this from the Spring and Tees working group chairs? Or there's something we missed? So Pavan shaking his head. I don't see Bruno. You're okay with this as it is? Okay. I think this was the last presentation for today and for the MPLS in Bangkok. See you all in Prague. Safe trips home and safe trips to Prague, and have a good time and review our drafts. Thank you. I have one more thing. Blue sheets. Can you pass them forward?